So as I said, each section is just another extension, another extension. So this section, 3-4, is called Beyond Cpctc. So we stopped with Cpctc last section, now just anticipate going another step further. So we've got 2 more vocabulary words. Median, it divides a segment evenly, or it bisects it. So it has very similar meaning as to what bisect actually means. It just cuts a side. All triangles have 3 medians to them. So again, median is very similar to bisect, but please, again, in a proof, just make sure that if it's talking about median or if it's talking about bisect, that is the word that you're referring to in the proof. Don't interchange them. It has to be the one that's being used. For altitude, that's a line segment that's drawn from any vertex of a triangle to the opposite side, making a right angle. So if you think back to some of the older vocabulary, that is similar to perpendicular. Same meaning, looks the same, it's just new word that's now replacing that. But again, they'll both be used throughout the year. Just make sure that you're using the correct one in the problem that you're working on. And just like a median, there's 3 vertices for a median, so there's 3 medians. Or there's 3 vertices in a triangle, so there's 3 medians. There's 3 vertices in a triangle, so there's 3 altitudes. All right, so let's consider that we have AB congruent to AC. And we know BD is congruent to CD. So the question is, can we prove that angle ABD is congruent to angle ACD? Based on this picture, no, we can't. But if you think about it, what would make it a lot easier is if we could draw in a line. Let's say if we wanted to add in AD. Well, that would close that shape up top to make 2 different triangles, and then we'd be able to have something to work with there. So this addition to the diagram, it's called an auxiliary line. And what you're going to be able to do is you're going to be able to draw lines in there. So the postulate that's associated with it is that 2 points determine a line. And this is what you'll be writing in a proof if you ever choose to add a line into a problem to make it a little bit easier for yourself. All right, so let's try example 1. So we're not going to use that mentality yet, but we will in a future problem here. So it says AC is congruent to BC. So AC is congruent to BC. AD is congruent to BD. And we want to prove that CD bisects angle ACB. So right off the bat, that's not proving triangle is congruent, and it's not a Cpctc. So this is a beyond Cpctc situation. So statement 1 is what we have in the given. Reason 1 is given. 2 triangles sealed together, we're going to use our reflexive property to say that CD is congruent to CD, and then the 2 triangles, ACD and BCD, are congruent by side-side-side congruence. Then if we're trying to show that CD bisects ACB, well, here's the angle, and we're trying to show that this bisects it. Well, if we think in terms of the triangle, the 2 triangles are congruent, but what will help me prove that? Well, what would help is if I knew that this top angle and this angle were congruent to each other. So that is what I would write with my Cpctc. Angle ACD and angle BCD are congruent, which then allows me to put my proof statement that says that CD bisects angle ACB. The reason, an angle is being bisected, so you write definition of angle bisector. Just make sure that that angle piece is there. You have to specify when an angle is being bisected. All right, next example here. So it says, given CD and BE are altitudes. All right, so there's one of our new vocab words of triangle ABC. And we know that AD is congruent to AE. All right, so we see, we're going to copy down our given. And right off the bat, we see the altitude idea. So we're going to write definition of altitude before we forget it. So don't just write the right angle symbols in there and then forget to write the step in the proof itself. So we're going to use the definition of altitude, and we know that angle ADC and AEB are right angles. All right, way back, we had learned that right angles are congruent to each other. So we can say that angle ADC is congruent to AEB because if angles are right, they are congruent. Now, in terms of looking here, we've got, these are called overlapping triangles. So absolutely, if it helps you to separate them, you can do that. But what you can do is if we look, let me shade these guys in here. So here's one triangle. And here's the other triangle. So we have to prove those triangles are congruent to get any further. Well, in order to do that, we look at these triangles and we say, okay, well, so far I've got a side and I have my right angles in there. So I either need another side or I need another angle. But if these two triangles are completely overlapping each other, just like a segment does, you want to look to use the reflexive property. And instead of it being a segment this time, if you look up top, they both share angle A right here. So if they both share angle A, that can be your reflexive. So we're going to say that angle BAC is congruent to angle BAC by the reflexive property. Then with those two triangles, if I were to just do a quick sketch here, so we have AEB and we have ADC, we have our right angles. We know this was congruent to this, and we have angle A up at the top there. We can now see that the two triangles are congruent by ASA. So ADC and AEB, those triangles are congruent by ASA. We're not done yet, so we know Cpctc comes next. So I have to prove DB and EC. Those are on the outside. So it makes sense to pick a side of the triangle to work with. So I'm going to use AB and AC to prove that this side is congruent to this side by Cpctc. And then given that I know that AD and AE are congruent, I can use then subtraction to say that DB is congruent to EC. All right, if you're ever unsure of what to put for Cpctc, in order to prove a triangle is congruent, you only need 3 items. So for Cpctc, just put the rest of them. Put all the missing sides and angles and you're good to go for that. All right, last and final one here. So it says G is the midpoint of FH and EF is congruent to EH. Congruent, congruent. So you see midpoint, which means we want to use it. So if it's a midpoint, it cuts a side in half. So we know FG and HG are congruent. Now, what would make the most sense? EG is not currently there right now. It shouldn't be there. So what we want to do is we're going to draw EG. So this was that new postulate. So if we choose to draw a line, which would make our life easier, what you would then say is 2 points determine, we're going to put a line just because that's what the postulate says. So 2 points determine a line. And that's your reason. That's it. You don't need anything else. Now, given that I have that line, I can now use the reflexive property to say that EG is congruent to itself, which now opens the door to the fact that the two triangles are congruent by side, 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 which then if I'm trying to prove that 1 and 2 are congruent, I want to get the guys next to it. So I want to get this angle is congruent to this angle by my Cpctc. So angle EHG and angle EFG are congruent by Cpctc. And then, again, forgetting a few things in here, I got to add 2 lines. I want to talk supplementary, so I got to add something in there. So line 7, I know that HGF is a straight angle. So I'm going to assume that from the diagram. Assume from diagram. And then line H8 would be the fact that it equals 180. So that's definition straight angle. Then my line 9 would be able to say that angle 2 is supplementary to EFG and angle 1 is supplementary to EHG, by definition supplementary angles. And then the last piece is I already know that this angle is congruent to this angle. So I have 2 angles, 1 and 2, that are supplementary to 2 congruent angles. Therefore, those angles are congruent.